Welcome Mark Michelson from Red Hat. He's going to talk to us about OVN performance.
Thanks, Ben. All right, so let's see. I got notes here, so that's what's in front of me here. So if you see me shuffling paper, that's what that's about. So last year I gave a talk about OVN performance, and it mostly just talked about changes that we had made in OVN and the performance impacts those it had. This talk's going to be a little bit different because I am going to do a little bit of that, but mostly we're going to talk about the current state of what we recognize as being the performance issues in OVN and what we potentially plan to do to address those. So giving you a top-level view of things right now, these are just sort of some observations we've made over the past year, especially since now Red Hat has customers that are actually using OVN in production. So first of all, one of the things that we notice is that we have very, very few reports about anything going wrong with OVN North D. However, if OVN controller has performance issues, people notice and people report them. So anyways, and the thing is, yeah. Anyways, next thing is, unfortunately, we're kind of at a point now where the lowest of the low-hanging fruit has been taken care of in OVN. It's not easy to just look at something and go, oh, I could have a fix that'll give us a 50% performance improvement in a day. That just doesn't really happen anymore. These days, if you want to make performance improvements, it requires some heavy profiling of specific scenarios in order to figure out what is actually wrong sometimes. Or in the cases where we do know what's wrong, it's considerably high risk to fix those things. One thing we found is that the performance results are situational. So we can run certain workloads and find that OVN performs completely amazingly, and then at other times we'll find that by tweaking the configuration some or using features in certain ways, all of a sudden now, you know, OVN controller is looping with 100% CPU, and it's a problem. And so what this has led to is that we have a philosophy these days of let's try as hard as we can to make it so that the code doesn't have to run, as opposed to making sure that the code that does run runs as efficiently as it can. So let's actually talk about some improvements that got made this past year. I'm going to give you a quick spoiler alert here. This is actually a pretty short section for this presentation. So sorry if I disappoint you guys with this. I picked specifically the ones with the biggest impact as opposed to just every single change that we made. So first of all, I think we have to start with incremental processing. Now, there's a tendency for people who are presenting to sort of present something as if they actually were the ones that introduced this, but I have to give huge props to Han for this because he's the one who wrote the incremental processing stuff for OVN controller. And he started on it about 1.5 years ago, but we didn't actually end up putting it in until about, I guess it was probably about 6 months ago now that it went in. But the philosophy behind it is pretty straightforward. The idea is that OVN controller previously had just always processed everything in the southbound database, everything in the OVS database, everything that it possibly could, and always performed the exact same actions every time it ran its loop. Unfortunately, this is incredibly inefficient when there's only a small amount of data changing. So the incremental processing engine sort of took it into its hands to try to make it so that we only process data that needed to be processed. And in the certain workloads that both Han and I tried out, we saw tremendous improvement in CPU usage, sometimes going down as low as 95% lower than what it had been before. In my opinion, the incremental processing change in OVN is the biggest single performance enhancing change that has ever gone into OVN, at least as long as I've been working on it. The next thing, it's kind of a cheat to talk about this because it's actually something that we disabled and then re-enabled again. But conjunctive matches are something I actually talked about in my presentation last year about how with ACLs, it can actually decrease the number of OpenFlow flows that get installed and thereby greatly increase the performance of OVN controller. So there was actually an issue with conjunctive matches, and we had to disable them. And then Red Hat actually put out a release of OVN that had conjunctive matches disabled, and people complained nearly immediately about how slow OVN controller was running. So we worked hard to reintroduce it, and the result was that a lot of the issues that were sort of snowballing from the lack of conjunctive matches ended up being fixed, and we even slightly gained a little bit better performance improvement than we had before we had disabled the conjunctive matches in the first place. So, with those in mind, let's talk about some of the performance issues that exist in OVN. So, I just talked about how great the incremental processing engine is, but unfortunately, it is not perfect. So, for one thing, it can't always incrementally process code. There are times where it just has to do a full recompute of everything and fall back to the logic that had been used prior to its introduction. I have some examples here on the slide. So for instance, if OVN controller disconnects from a database and then reconnects, the incremental processing engine thinks it might have missed some updates and therefore has to do a full recompute of everything. Similarly, if the incremental engine runs and it finds that it can't send OpenFlow because the socket is being used, there's still messages in flight, it'll abandon what it tried to do and then do a full recompute next time. And then also, when Han wrote the incremental engine, it was targeted for, let's just call them, say, common workloads. And unfortunately, what that means is you can come up with some that don't take advantage of incremental processing as much as we would like. A good example of that is if you are adding and removing data paths frequently as part of your workload, then you may not see the benefits of incremental engine as much as others. So another problem with the incremental processing engine is that the code is just pretty complicated. So when you're taking C code that is very iterative and does the same thing on every loop and try to turn that into a dependency graph of data and how it relates to each other, it's a tough dance to get exactly right. And so when I say it's complicated, what I mean by that is that it can be difficult to debug whenever you come across problems with it. And I know every time that I look into it, for instance, if there's a patch or something, I find myself kind of having to relearn it again as opposed to just picking it up right away immediately. And because of the recomputes that the incremental engine does, there can be times where you can end up never being unable to recompute. So an example I have written down here, when we disabled conjunctive matches, we had some customers who would run OVN controller with lots of ACLs, and they found that a single loop of OVN controller might take as long as 60 or even 80 seconds to run, just because it was having to generate so many OpenFlow flows, and it just was incredibly inefficient. Well, when it takes that long for a loop to run, if you have, say, an inactivity probe configured of 5 seconds on your database server, then we're not responding to that inactivity probe within the 5 seconds. We disconnect from the server, so then the loop has to run again. It sees that it's disconnected from the server and needs to reconnect. The incremental engine thinks, oh, I might have missed some updates, and therefore does a full recompute again for another 60 to 80 seconds. So you can end up with these. Now that's a bit of an exceptional case because it's something we were able to fix just by the reintroduction of the conjunctive matches. But there can be other situations too where this can happen where you wouldn't expect it to. And I already mentioned about how there are certain workloads that just aren't conducive to incremental processing. And while those haven't necessarily been seen in production at this point, the fact that we know that they exist and the fact that we know that we might come across them is, I don't know, a little bit scary, I guess. So another problem that we face performance-wise in OVN controller right now is it's called pin control in these slides, but that means packet in control. So OVN controller both has the job of creating OpenFlow flows for OVS, but it also handles certain types of packets that come in, such as DHCP, ARP, and if you have it configured, it can actually do DNS resolution too. Now, earlier this year, we actually separated pin control into its own separate thread instead of it being run in the main loop of OVN controller. And honestly, I probably could have put that as one of the big performance improvements that we made this year, except that the incremental processing kind of just superseded that in my mind. But having it in a separate thread is a good thing, but there are still problems. So for one thing, we have pretty coarse-grained locking being used. So there's a single lock that gets locked for the entire time that the pin control stuff is getting processed in the main OVS thread. And so that can potentially block us from processing incoming packets. And if we block for long enough, for instance, we may not be able to respond to those packets in time, causing those packets to get retransmitted again. And then if we block again for that same length of time for some reason, then again we can find ourselves in this weird loop where we just loop 100% continuously. And you could also potentially even have the same in reverse. The packet processing could, for whatever reason, take a long time, blocking the main loop, making it unable to respond to inactivity probes or anything like that. Now, we haven't seen that happen yet, but it's just something that potentially, in theory, could happen. OVN controller itself, even when you have it in the best circumstances, we're aware that there are just places where algorithmically it might make sense to make some improvements. So during a full recompute, even if you have conjunctive matches being created, even if it doesn't have to wait on the pin control lock, you could still find it taking somewhere between 2 and 4 seconds to run a loop, which in terms of the types of numbers we talk about here at a conference like this, that's years, it seems like sometimes. And when we've done profiling, what we found is that the biggest offenders are expression parsing of logical flows and generating large numbers of open flow flows. And while we've done things to try to mitigate the amount that runs by, for instance, having incremental processing make us not always parse all of the logical flows, there's just times where you are going to have to do a full recompute no matter what, and it would be great if our loop times could get a little bit lower. The problem is that it's not an easy thing to squeeze out more performance out of this. To give a good example, I know my colleague Dimitri did some profiling and was able to get about a 15% improvement by doing a few small things, but after that it was down to the point where the risk-reward factor was a little bit too high to just go forward any further. All right, so let's go through the big list of planned improvements. And based off of the problems that I talked about, these shouldn't be too surprising. Okay, so first of all, I have this sorted, by the way, the list here. It's sorted from, I'll call it easiest to most difficult changes. So at the top of the list, we have make incremental processing work for more data types. Now, anyone who works on OVN probably says that's not easy at all, because it's not really. But amongst all the things on this list, I think it is probably the easiest to do. So, and the reason I also say put it at the top of this list is just because it's the one thing we all recognize as being something that can be improved. I think probably the most crucial data type that could have incremental processing added for it would be the addition and removal of data paths. But other than that, it would probably be take it one at a time as we come across them in actual production scenarios. The second item would be to reduce situations where a full recompute of the incremental engine is necessary. So a good example of this is one that I actually mentioned earlier, which is where if we are unable to send OpenFlow messages to vSwitch, we currently do a full recompute again. And it's possible that because we know in that situation that we haven't missed any southbound data or anything, it could be that depending on what data had been processed, we may not actually have to do a full recompute on the next cycle. It may be that we're actually fine to incrementally process whatever comes next. The next item is to reduce the contention between OVN controller main thread and the ping control thread. This is something that I have discussed with a few people at this very conference, a lot more than I actually expected to. We have lots of ideas about how it could be done. I made a proof of concept earlier this year where I actually separated ping control into a separate process instead of it being in a separate thread. But the concern there was that that doubled the number of connections between nodes and the southbound database, and that southbound database may not be able to scale to that level of connections. And so we're coming up with other potential ways of doing it, including potentially just making the locking finer grained, or making it so that the threads, the contention is done at the IDL level as opposed to at the OVN controller level. And then the next thing is the making algorithmic improvements to OVN controller. The reason why I have this one so far down the list is because we've taken a pretty good long look at this already and coming up with ways to do the improvement without going crazy or risking worse consequences than what we already have. It makes it a difficult thing to do. But since we already do know 2 places in OVN controller that have consistent slowdown, looking at ways of improving expression parsing, looking at ways of making the open flow generation potentially better are things we've looked at. Ideas we've come up with have been to cache results from previous runs so that potentially we don't have to just regenerate things if we don't have to. But so far we haven't actually been able to do that and do it in a way that proves that performance actually improved. And then at the bottom of the list here, I have the conversion to differential data log, or DD log. So Dimitri and I gave a presentation yesterday about DD log, so I won't talk too much about what it is, but it's pretty obvious that converting from one language to another is just a pretty monumental effort. And so the risks of that are pretty high. So that's why I put it as the final item on this list. And that's all I have to talk about. Let's go get ice cream.
All right, we have time for questions. Who has a question?
Thanks, Mark. Did you also notice any issues with using JSON RPC between OVN controller and OVSDB southbound versus using some kind of a binary format? Was serialization and deserialization also part of heavy CPU utilization?
So the question about using JSON RPC versus some sort of binary format, I guess the idea is that the binary format would just be less data to have to process. Well, so far that hasn't actually shown up in any of the the perf testing that we've done. If it's there, it's dwarfed by the amount of CPU that expression parsing of the logical flows takes. So and it may be that that ends up bubbling up the list at some point, but as of right now, that has not been a bottleneck for us at all. Any other questions?
Are there any questions online? Oh, one more here.
Like all of your customers who reported this issue, do you know the scale of the cluster that they were using? Was it like hundreds, or was it like in close to thousands?
Sure. So from what I know, the number of nodes for these customers was not particularly large. We're actually talking about somewhere in the 30 to 50 node range, which is, again, but the thing is, the biggest thing that these customers were doing was they were running OpenStack systems that had lots and lots of ACLs. And the ACLs in this particular case were resulting in lots more logical flows to process. And if conjunctive matches were disabled, it also resulted in quite a lot more open flow flows being generated as well. So those were sort of the circumstances behind that. So it wasn't really bounded by the number of nodes, but more by the security policies that were being installed on the systems.
Anybody else?
I'm curious, may not be just for this session, in general on OVN, is any thought went on anywhere to make it more microservice architecture based, where this OVN controller and other processes become containers and you have scale out option, the way in Kubernetes does, right? When some particular container is basically use up a lot of CPU, it automatically brings up another container, and then there's a load sharing. So any thought process went in that direction?
There might be an issue there that once you start having those, you need to network them together.
Yeah, so Ben, you did bring up a good point there. But I would say you can talk to several people who are deploying OVN places, and one of the things that they're being told by is try to minimize the number of processes that are going out there, just because as you add more, you just have more points of failure. Now, as far as containerization goes, I mean, there are people who run OVN controller in, I believe, in containers right now. But as far as trying to minimize what gets done, the closest I've come with this talk was talking about separating the packet in controller into a separate thread separate process. And the reason why that came up is because it really is distinctively different from what the rest of OVN controller does. But it still relies on some of the data that OVN controller gathers. And so you'd either have to have, I don't want to say another database for both to use commonly, but you would have to have some sort of inter-process communication between the two, or else you're going to duplicate the effort that both are doing just to get some of that common data that they both need. Again, I have to say the word microservices has never come up in conversations that I've had with people about improving performance in OVN. But it's definitely something to think about, I suppose. If we can minimize what a certain process does to a certain subset of what it does now, then perhaps that's a smart idea.
So I do know that one of the attractive properties of OVN initially in OpenStack was that they didn't have to run as many services. From that perspective, it might be a step backward to start dividing it up into a bunch of services. All right, so we have about 25 minutes now to go and make yourself an ice cream